Okay, folks, let's crank it up a notch with example 5. So all of these examples are going to have trinomials where the lead coefficient is not 1, right? You can see here 2, 8, I think you can see 6 and 16. So we're going to go through this AC method, right? And we're going to see it work even when the lead coefficient is not 1. It makes your problem slightly more challenging, but it's still the same idea as everything we were doing in example 4. So here I have A is 2, B is -7, C is -15. So if I think about my product, right, I always want my product to be AC, which in this case is 2 times -15, which is -30, right? And then I want to find something that's going to sum to B, which is -7. And I'm not going to go through and list everything like I did last time, but we can just start to think, what are some numbers that multiply to 30 and add to 7? And you can see 10 and 3 are a good combo of that. And since I need it to be -30, I need to either have -10 or -3. Like one of these two numbers has to be negative. But if it needs to sum to -10, I'm going to put it needs to sum to -7. I'm going to put the negative on the 10. And -10 plus 3 here is -7, so I unlock it. All right, so once I figure out the unlock, I'm going to look at 2x squared minus 7x minus 15, and I'm going to rewrite this middle term, right? That whole split the middle term as 2x squared. I'm going to go minus 10x plus 3x minus 15, right? So instead of -7x, I split it as -10 plus 3, because -10 plus 3 is -7. But now we group. And let's see what we get. The GCF here is 2x, and we have x minus 5. The GCF for these back two terms is 3, and I have x minus 5. Right? So since that back term, that back binomial factor is common, I'm going to factor out x minus 5, and I'm going to be left with 2x plus 3. Right? And you can't quite see that parentheses. Let me make that there. And you could always check this from foiling. All right, so same idea, just slightly more intricate with that lead coefficient being something other than 2. All right, so here we had what? A is 8, B is -13, C is 5. Let's go ahead and take a look at this. So if I want the product is always AC, so in this case that is 8 times 5, which is 40. All right, and then I need the sum. Let's see, what was my B value here? It looks like it was -13. So I need to think of numbers that multiply to +40 and add to -13. And actually 8 and 5 are pretty good indicators, right? 8 times 5 is 40. Now 8 plus 5 is not -13. So I'm going to switch this and make this -8 times -5, right? Because -8 minus a 5 is -13. So once I've unlocked that, let's rewrite this middle term. So instead of 8t squared minus 13t plus 5, I'm going to write this as 8t squared, all right, minus 8t minus 5t. And then I'm going to do plus 5, right? Instead of -13t, I'm going to split it. And again, I could have gone minus 5t minus 8t. It would have gotten us to the same end game answer, just a slightly different path along the way. All right, let's group. First two, last two. All right, GCF to 8t squared and 8t is 8t. I'm going to be left with t minus 1. I've got -5t plus 5. Let me take out -5 instead of just +5 and get t minus 1. Makes that back binomial match. I can factor out the t minus 1, and I am left with 8t minus 5. Right? Which I can always check by foiling. That's the lovely thing in this. Foil these back out, you're going to get to your original problem or original expression. All right, let me scooch this up so we can take a look at C and D. All right. Now, something to notice on C, I see that there's a GCF right out the gate. Right? I see 6, 3, and 63. They have 3 in common, so I'm going to factor out the 3 to get 2x squared minus x minus 21. Now again, if you want to guess and check this, that is totally fine. I'm going to AC method just so we have that as an example. Now I'm going to use the numbers from the factored form. So I'm going to say A is, what do we got, 2, B is -1, and C is -21. If you wanted to rework this with 6, -3, and 63, you absolutely could. You're just going to have larger numbers. And since I already factored out the 3, as long as I keep a 3 on the side for the rest of my work, I'm good to go. All right, so if I want product, let's get the product of AC, right? In this case, it's going to be 2 times -21, which is -42, okay? And then if I want to sum, my middle term was, -1. Okay, so then when I start to think about how this is going to work, right? If I think about things that multiply to 42, 6 and 7 are coming to mind. And I'm going to use 6 and 7 because I know that they're only off by 1. So if I think of 6 times 7, first of all, that is not -42. That is positive 42. So I'm going to need a negative either on the 6 or on the 7. But if they need to add to -1, I'm going to put the negative on the 7. Right? Because then 6 plus a -7 is -1, and I've unlocked it. All right, let's split the middle term. So here we go. I'm going to keep this 3 on the outside. And I'm going to go ahead and split this term. I'm actually going to use brackets just so we have larger grouping symbols. So I'm going to write 2x squared. Instead of minus x, I'm going to do plus 6x minus 7x. And then what do we have here? Minus 21. All right, let's group first 2, last 2, and see what we're working with. So I'll keep the 3 on the outside. All right, between 2x squared and 6x, I'm going to have 2x as the GCF and be left with x plus 3. -7x minus 21, I'm going to take out the -7. I'm going to be left with x plus 3. That back binomial factor matches. That is great. I'm going to factor that out. So I'm going to have 3, and I have x plus 3. Right, and what was I left with? 2x minus 7. Right, and I could always multiply this together, see if I get back to my original expression, and if I do, I'm just that much more confident that I have the correct answer. Okay, this one looks like a beast, right? So this, I would say A is 16, B is 56, right? C is 49. I've got that trinomial. So let's look at our product. All right, my product is going to be A times C. So in this particular case, we're going to have 16 times 49. And when I take a look at that, that is 784. And then I want to see how can I sum to 56, okay? And this will come down to, do you recognize this number as a perfect square? And you may or you may not, all right? And it's okay if you don't, but you could go through all the numbers that divide into 784, and there are a ton. But eventually you're going to see that 28 times 28 is 784, and 28 plus 28 is 56, right? So I'm not saying it'd be easy to get there, but we could get there, okay? All right, so if I start to simplify this, right, 16m squared plus 56m plus 49 can be rewritten as 16m squared plus 28m plus 28m plus 49, right? Group. Okay, so what's common to 16m and 28m? I can take out a 4m, and I'm left with 4m plus 7. And then that can kind of help you on this back end, right? What's common to 28m and 49? Well, I know I want a 4m in that position, so you can see I can factor out that 7, right? And I get 4m plus 7. Back binomial factor is common. I'm going to go ahead and factor out that 4m plus 7. And again, I'm left with 4m plus 7. And so we actually had a perfect square trinomial. This is 4m plus 7 squared. Okay? All right. Let's keep on moving on, right? These start to get not super complicated. Well, maybe you feel they're super complicated, but they get a little bit more convoluted, that's for sure. Okay, if I'm looking at E, I can see there's a GCF, right? 18, 63, and 27 definitely have a 9 in common. Oops, sorry. I just saw that my camcorder is blurring out a little. I'll get it focused. All right, 18, 63, and 27 have a 9 common, and then p to the 4th p squared, p to the 4th p cubed and p squared also have a GCF of p squared. So let's take out the 9p squared, and we'll be left with, all right, 9 to get to 18 is 2, p squared to p to the fourth is 2p squared. All right, 9 to get to 63. Oh, you know what? I'm gonna run out of space. Let me put it on the line below. All right, so let's take out the 9p squared. So we said this was 2p squared. All right, to get to 63, so we'd have 7p. And then in the last position, we would just have a 3. Right? So for this problem, and I'll go ahead and put a little separation here. What do we have? A is 2, B is 7, C is 3. So if I think about my product, right, if I want AC, that's going to be 6. Well, I'm going to barely have room. Sum in this case is 7. Okay. What multiplies to 6 and adds to 7? Well, literally 6 and 1, right? Because 6 plus 1 is 7. So I've unlocked it that way. So let's go ahead and split this middle term. All right, so I've got 9p squared. All right, so I'm looking at 2p squared plus, what do we have? 6p plus p plus 3, right? And you could have done p plus 6p here. You would have gotten to the same end game answer. All right, I got 9p squared. All right, so common GCF to 2p squared at 6p is 2p. And I'm left with p plus 3. And I actually already have a p plus 3 here, so I'm going to kind of write that as a 1 to that binomial of p plus 3, right? That placeholder of 1. And then I have that p plus 3 common. So I'm going to factor that out. And I'm going to be left with what? 2p plus 1. Okay. All right, so taking a look at F, we're almost to the end of this, right? These start to get very convoluted and intense, but I can also see that I have a 3 common, right? I have a GCF, so I'm going to factor out the 3. 2a squared plus, what do we got? AB minus, if I take out the 3, I got 6b squared. Okay. So I'm going to double up on the letters A and B, in that I'm going to say A is 2. What do we have? B is positive 1. And C is negative 6. So I do want to acknowledge there's A's and B's in the original problem because those are the letters. And I'm just representing A, B, and C as the coefficient of this trinomial here. All right. So what do we need? We need a product of AC. All right. AC this time out is 2 times negative 6, which is negative 12. And I need those to sum. All right, what was my B value? 1. All right, so what multiplies to 12 but it's off by 1? I'm going to do 4 and 3. And I need it to be negative 12 that they multiply to. So either the 4 is negative or the 3 is negative. But I need it to sum to positive 1. So I'm going to want positive 4 and negative 3. Because 4 minus 3 would equal 1. Okay, so let's do this. Let's not forget our initial 3. All right, I've got 2a squared. Instead of ab, I'm going to write 4ab minus 3ab. Right, because 4ab minus 3ab is positive 1ab. Can't forget my minus 6b squared. Right, and it's time to group. Right, first 2, last 2. So, all right, let's keep the 3. All right, common, the GCF to 2a squared and 4ab is going to be 2a. And I'm going to be left with what? A plus, I need 2b here, right? And if it gets to be too much, you can check. 2a times a is a squared. 2a times 2b is 4ab. I'm going to definitely take the negative out from here, and I'm going to factor out a b. And when I get left with that, right, if I factor out the negative 3b, I have an a plus 2b. Great, because that binomial is matching. That's always a good sign. So I'm going to factor that out. So I have 3, I have a plus 2b, and what do I have left? 2a minus 3b. All right, that is a beast, but we got there. All right, thanks so much, everyone. Bye.